applied chemistry, is an important work group in charge of giving rules to different aspects in chemistry, as the periodic table, its order, rules for a new element, etc. Thanks to this institution, we are able to name the hydrocarbons in an ordered way that is standardized, and because of that, it can be understood in every part of the world.
First, we have to define what is a hydrocarbon. Any of a class of organic chemical compounds composed only of the elements hydrogen and carbon. The carbon atoms join together to form the framework of the compound, and the hydrogen atoms attach to them in many different configurations. Hydrocarbons are the principal constituents of petroleum and natural gas. They serve as fuels and lubricants as well as for raw materials for the production of plastic, fibers, rubber, solvents, explosives, and industrial chemicals. The structures and chemistry of individual hydrocarbons depend in large part on the types of the chemical bonds that link together the atoms of their constituent molecules.
Saturated hydrocarbons, where we found alkanes, hydrocarbons in which all the bonds are single and are saturated with hydrogen. They are called saturated because each carbon is bound to 4 other atoms. Have molecular formulas that satisfy the general expression CnH2n+2, where n is the number of carbon atoms. The name is derived from the Greek or Latin name from the number of the carbon atoms and the suffix ane.
Have unsaturated hydrocarbons. They have only one or more double or triple bonds between carbon atoms. Here we can find alkenes that contain one or more double covalent bonds between carbon atoms in a chain. The general formula for this series is CnH2n. They have the suffix ene. Then we have alkenes that contain one or more triple bonds between carbon atoms in a chain. Triple bonds involve the sharing of 3 pairs of electrons. The general formula is CnH2n-2. They have the suffix yne. And finally, we have cycloalkenes. Are organic compounds that contain a hydrocarbon ring. The prefix cyclo is used with the hydrocarbon name. They only contain single bonds. And finally, the aromatic hydrocarbons, which are organic compounds that contain benzene rings as part of their structures, are 6-sided structures with a single and double mobile bonds. Their circle in the middle of the hexagon symbolizes the cloud formed by the 3 pairs of electrons.
Okay, first of all, we have to know what an alkane is. So we are going to start with a single definition, which is, first of all, for understanding what alkanes are, we have to know 4 single details, which are that they are saturated hydrocarbons. Also, that because of the prefix ane, that means that they have only single bonds, and that is represented by this, just a single line, and that it has a general formula, which is CnH2n+2. An example of this can be, I don't know, if n is equal to 7, then this will be like this, C7 and H16. Now, there are 6 steps just to name the alkanes. They are very simple. The first one is to identify the longest chain. The number 2 is to number the carbons from the ending closest to a substituent. The number 3 is to identify those substituents. The number 4 is to name the alkyl groups in alphabetic order with their location. Number 5, at the end, name the parent chain with the prefix "and" and the word "ane." Why ane? Because we're naming alkanes. And finally, number 6 is to separate numbers from numbers with commas and numbers from letters with hyphens. Don't worry if you didn't understand those steps, because here we have a very easy example. First of all, we have to identify the longest chain. We have a lot of possibilities. We have this one, or maybe this one, or this one. But we remember that we have to have the longest chain, so we're going to use this one, and this is our parent chain. The number 2 is to number the carbons with the closest substituent. We're going to start from here. Why? Because this one is our closest substituent. So we already named it from 1 to 8. Now, we have to identify the substituents. Here we have an ethyl and 2 methyls. The ethyl in carbon 4 and the methyl and both methyls in 3 and 5. Now, we have to name it in alphabetical order. Which letter is before E or M? I think we all know the answer. It's letter E. So we're going to start with ethyl. So we're going to start with like this: 4 ethyl, 3,5 dimethyl, and octane. Why octane? Because 8 carbons, and the prefix ane because we're naming alkanes. And that's it.
Well, now we're gonna talk about alkenes. Of what are they and how to name them. Well, first of all, the alkenes are hydrocarbons that have one or more double bonds in the chain. For naming alkanes, you should take the larger chain that has the double bond. In this case is this one of here. The first step is to define if the chain is numbered from the left to the right or from the right to left. As in this case the double bond is near to the left, it will be numbered from the left to the right. Well, then after numbering the chain, we have to start naming the alkene. Well, first of all, you have to see that methyl is the only substituent in this alkene. So you have to look for which alkane is situated. As you see, it is the 4th one. 1, 2, 3, 4. So the first part of the name of the alkene is 4-methyl because it's situated in the 4th carbon, and then 2-penthene because it is the 2nd carbon, which is situated the double bond, and are 5 carbons in the chain. So the name would be this one, 4-methyl, because the methyl is situated in the 4th carbon, as you can see, and 2-penthene because the double bond is situated after the 2nd carbon, and penthene because there are 5 carbons in the whole chain. Well, then are the alkynes, that are hydrocarbons that have one or more triple bonds in its chain. In the naming part is really similar to the alkenes. It's just that in the ending part of the name, instead of in is ein.
The aromatic compounds are the ones that contain the benzene ring and have 6-sided carbon with 3 double bonds in resonance. To name compounds with one substituent, we have to add the name of the substituent to the benzene. For example, the compound with one hydroxide will be hydroxybenzene, and it has the common name phenol. To name compounds with 2 substituents, we have to use the simplest numbers, and according to this, we use one of these prefixes. In this case, we have 1 ethyl and 1 methyl, so it is named 1 ethyl 2-methyl benzene or orthoethyl methyl benzene. When there are 3 or more substituents, only numbers are used. In the example, we have 1 substituent of bromine, 2 methyls, and 1 chlorine, so the compound is called 1 bromo 5 chloro 2,3 dimethylbenzene.
After all we watched at this video, we can conclude that naming hydrocarbons and drawing its structural formulas is a very easy thing to do. But we have to mention that it can get a little complex, because you have to learn many concepts that can be a little similar but with different suffixes. So this can make this activity a little confusing, but with the time, as you acquire practice and learn everything completely, it is a very simple thing to do. And also it can be very interesting.
In my personal thought, I think that this topic is easy, but at first it seems to be confusing because of all the carbons and all the long chains and the steps that you need to know and that stuff. But I think that with the practice you can master it. So when you learn it correctly, it doesn't seem to be that difficult. It actually turns something easy.
As a personal opinion, I think that it's interesting to know more about hydrocarbons, including the alkanes with single bond, the alkenes with double bond, alkynes with triple bond, and the aromatics with the benzene ring. It is also interesting to know about how are they named and the process of it. At first it looks complex and hard, but then it turns interesting and a little fun.
These rules for naming hydrocarbons are very important for the scientific community. Nowadays, it is necessary as a universal way of recognizing compounds, and for this reason, it is so useful. The UPAC does a great job putting these guidelines, and this work helped me a lot to understand the subject by taking one of the most extensive parts, and despite doing it so briefly, I realized that the rules that we must follow are simple.
The making of this video was a useful activity because in this way we could review what we learned in class, and also we can help other people to understand this topic. We can conclude that this topic is simple and it also can be fun and interesting, but it requires that you know all the concepts involved and its definitions. Because if you don't know them and you are an expert in this field, then the things can get a little complicated. But then of a few practices and exercise, I'm pretty sure that you will be able to entirely do this by yourself and in an easy way. Finally, here is another proof that chemistry is involved in our everyday life and it is a very fun and interesting activity.
Yes, science!